We have talked about the notion of sampling variability. That is, our statistic is going to vary a little bit from sample to sample. We already knew this before coming into this class. Now we're going to formalize what we do with this information. Example 4. PewInternet.org is another website run by Pew Research. And in one of their recent reports, The Best and Worst of Mobile Connectivity, they report that 85% plus or minus 2.4% of American adults own a cell phone. Where does the plus or minus 2.4% come from in this example? This is called the margin of error. Often, instead of writing out the words margin of error, we're going to abbreviate that MOE. The margin of error is a value that quantifies the uncertainty in our estimate. Let's think about what we mean by uncertainty in our estimate. Well, if we understand that every sample is going to look a little bit different from every other sample, even if they're taken from the same population, we called that sampling variability. Therefore, the statistics calculated on those samples are also going to be a little bit different from each other. So if we're using the sample proportion to estimate the population proportion of some trait, there's going to be variability from sample to sample in that statistic. And that statistic is estimating our parameter. So since there's variability in that statistic, we say there's uncertainty in our estimate. Sometimes we get a p-hat that estimates the population proportion a little bit too high. Sometimes we get a p-hat that estimates that population proportion a little bit too low. We just hope that our estimate doesn't swing too high or too low, and that on average, it's hitting our target. That is, on average, it's estimating our population parameter. So when using the sample proportion to estimate the population proportion, the margin of error is a measure of how close we believe the sample proportion is to the population proportion. We usually report this through a confidence interval. More on that coming soon. When using the sample proportion p-hat from a simple random sample of size n to estimate an unknown population proportion p, the quick formula for margin of error under something we call 95% confidence is, we're going to put is approximately equal to the approximate margin of error for 95% confidence is 1 divided by the square root of n. That is 1 divided by the square root of our sample size. Remember, that quick formula that we gave for the margin of error for 95% confidence is just an approximation to the actual margin of error. We're going to refine that approximation in Chapter 21. For now, we're going to use our quick formula for margin of error. Suppose a poll interviewed 1,000 people. What is the margin of error of p-hat for 95% confidence? Use the quick formula. Well, our margin of error is 1 divided by the square root of n. And what's n here? Remember, n stands for sample size. Our poll interviewed 1,000 people, so our n is 1,000. So it's 1 divided by the square root of 1,000. If you punch that in your calculator, you're going to get 0.0316. Let's change that to a percentage. That would be 3 3.16%, and we'll round that to 3%. Margin of error attempts to quantify how far off our statistic is from the parameter we're trying to estimate. Margin of error tells us how far off our estimate that is the statistic, is from our target, the parameter. We formally quantify this offness by combining our statistic with our margin of error to form what we call a confidence interval. The form for most confidence intervals is your estimate plus or minus the margin of error. We have a specific estimate. We have a specific estimator that we're using here in our examples. That is, we're using p hat to estimate p. So let's write down our confidence interval when we're using p hat to estimate p. The approximate 95% confidence interval for p is our estimate, and that is, we're using p hat to estimate p, plus or minus our margin of error, and our margin of error for our estimator, using the quick formula, is 1 over the square root of n. So this formula is what we're going to use to calculate confidence intervals. A confidence statement interprets a confidence interval and has two parts, the margin of error and the level of confidence. The margin of error says how close the statistic lies to the parameter. The level of confidence says what percentage of all possible samples result in a confidence interval which contains the true parameter. Going back to our example from Pew Internet, where they estimate 85% of all U.S. adults own a cell phone, plus or minus 2.4%, we're going to compute and interpret our first confidence interval. Our confidence interval for P, using p hat as our estimator, is p hat plus or minus our margin of error. Now this margin of error would be 1 over the square root of n, but notice in our example, this has already been calculated for us. Now what do we mean by this plus minus sign? Here we go. That is, p hat is 85% plus or minus 2.4%. So the 85% was the p hat, and the margin of error was reported to be 2.4%. And now we're going to deal with that plus minus. What we're going to do is we're going to take 85 minus 2.4 to get our lower bound for where we think our population parameter is. And then we're going to take 85 plus 2.4 to get the upper bound for where we think our population parameter is. So if you take 85 minus 2.4, 85 minus 2 is 83, and minus the other 0.4 leaves you with 82.6. You could punch that in a calculator if you wanted to. So our lower bound for where we think the population proportion is 82.6%. Less than our population proportion, less than our upper bound, 85% plus 2.4%. So our upper bound is 87.4%. Now let's take a look at these symbols that we wrote here. So we said 82.6% is less than P is less than 87.4%. What does this mean? Well, P is our population proportion. Make sure that you're not writing your sample proportion here, p hat. We know what p hat is. It's 85%. We calculated that from our sample. We're using p hat combined with our margin of error to try to estimate where the population proportion is. So we think that our population proportion, P, is between 82.6% and 87.4%. That is, we think that between 82.6 and 87.4% of all U.S. adults own a cell phone. A common way that you'll see confidence intervals written in the media is to not put the parameter in there. It's implied to be understood what the parameter is from the context of the writing. Lots of times they'll just put the two endpoints of the confidence interval separated by a comma inside parentheses. So these are equivalent ways to write our confidence interval. Let's formally interpret our confidence interval. We always start off by stating our confidence level. we can say we are 95% confident that the percent, and remember this is about our population, not our sample anymore. We used our sample to say something about the population, so it's incorrect to talk about the sample. We want to talk about the population, and our population is all U.S. adults and our parameter is the percent of our population that own a cell phone. Is between 82.6 and 87.4%. So notice the ingredients here. We're stating our confidence level. We're talking about the population, clearly defining our parameter, and then giving our confidence limits with any appropriate units. Let's try another example from start to finish where we compute and interpret a confidence interval. Another report from Pew Research on their Pew Social Trends website. In May 2011, a survey found that 57% of the 2,142 adult Americans polled think that the higher education system in the United States fails to provide students good value for the money they and their families spend. Using the quick formula for margin of error, compute and interpret a 95% confidence interval for P. So where do we start? We need to compute our confidence interval first. Our confidence interval using P hat to estimate P is P hat plus or minus 1 over the square root of n. So we need to compute or find P hat from our example, and we need to compute or find the margin of error. P hat from our example is 57%. So we've got that part down. 57% is our P hat. The survey found that 57% of the people polled think the higher education system in the United States fails to provide students good value. Now we can compute our 1 over the square root of n. 1 over the square root of n, in this case, our n, our sample size, how many people were polled, is 2,142. And if you punch that in your calculator, you're going to get 0.0216. And we're going to round that. So that would be 2.16%. And we're going to round that to 2%. So our 1 over the square root of n in this formula ends up being 2%. So now we can finish computing our confidence interval. We've computed our P hat, we've computed our 1 over the square root of n, our margin of error. 57% minus 2% is 55%. Less than P, less than our upper bound. 57% plus 2% is 59%. So our confidence interval, we think the population proportion lies between 55 and 59%. So now we can interpret this confidence interval. Remember that we always start off by stating our confidence level. Our example uses 95% confidence. That's the only confidence level you've learned. So we'll state that. We are 95% confident that, and what are we looking at here? It's the population proportion of something is between 55 and 59%. And here, it's that adult Americans think the higher education system in the United States fails to provide students good value. So we're 95% confident that between 55 and 59% of our population, of all adult Americans, think what? The higher education system in the United States fails to provide students good value for the money they and their families spend. So let's check out the ingredients of this confidence interval statement to make sure we've met all the requirements. First, did we state our confidence level? Yes, we're 95% confident. Did we state our confidence limits with the correct units? Yes, they're right here. Did we talk about the population and not the sample? Yes, we talked about all adult Americans. Did we clearly define the parameter? Yes. That's the percent of the population that think the higher education system in the U.S. fails to provide students good value for the money they and their families spend. Some notes about confidence intervals that are extremely important. The conclusion of a confidence statement always applies to the population, not the sample. Never talk about the sample when you're talking about a confidence interval interpretation. Our conclusion about the population is never completely certain. We're never going to have a 100% confidence statement. If you want a smaller margin of error with the same confidence, take a larger sample. Remember that we said before, taking a larger sample reduces variability. Well, margin of error quantifies the variability in your estimate. So it would make sense that taking a larger sample would reduce the margin of error. It is very common to report the margin of error for 95% confidence. If the level of confidence is not mentioned, you can assume it's 95%. That's how common 95% confidence is. You can use other levels of confidence other than 95%. Other popular levels are nice round numbers, 80, 90, 99%. Increasing the level of confidence for a fixed sample size makes your interval wider. So if you're 99% confident rather than 95% confident, you've got to cast a wider net to catch that parameter. So increasing the level of confidence makes your range of values have to be a little bit wider. You're more confident, so you have to give a wider range of values. A good way to remember this that came from a previous Stat 110 student is if you're trying to catch more fish, if you want to have a higher chance of catching your fish, you've got to get a bigger net. So increasing the level of confidence makes you have a wider range of values. For a fixed confidence level, increasing the sample size makes your interval narrower. Let's talk about this one. We already noticed that increasing the sample size reduces variability in our statistic. We also tied that to increasing the sample size, therefore, makes the margin of error smaller. If the margin of error is smaller, your range of values for your confidence interval is narrower. These are very important facts that we're going to want you to know. We ask these on almost every single exam, so make sure that you make little note cards to remember these. The variability of a statistic from a simple random sample does not depend on the size of the population, as long as the population is at least 100 times larger than the sample. If we take a sample of size 2527 from a population of 300,000, and then we take that same sample size from a population of 1 million, which sample statistic would have more variability? Neither. The variability depends on the sample size, not on the size of the population. Now, some little notes to help you remember these two extremely important facts is increasing the confidence level increases the width of the interval. Increasing the sample size decreases variability, which decreases margin of error, which decreases the width of the interval. Another way that we say that is it makes our confidence interval narrower. So increasing the confidence level makes you have a wider interval. Increasing the sample size makes you have a narrower interval.